You can read about this in a paper. We used the word refactoring in the paper, stealing from computer science, because we thought we were rewriting a code to make it easier to understand. In this case, it was a genetic program. So that was a couple years ago. Having had this one experience, it became more interesting to think about, well, let's not start with the things that already exist. Let's develop generic frameworks for programming any new genetic system we want, building on the bits and pieces that might exist, but assembling them anew. So as a toy problem, for example, if you have these bacteria that live in your gut, and sometimes they make odors which aren't so pleasant. And so what if you could reprogram E. coli to smell like mint or wintergreen while the E. coli are growing, and then as bananas while they're not growing? Bacteria, they grow and then they rest and so on. I'm in the biological engineering department at MIT, and if that department was really up to speed, right, of course we could do stuff like this. Right, because bananas smell like bananas and mint smells like mint, so all we need to do is port that over into bacteria, and then we'll have eau de coli. The questions that come up are, what language should I use? What's the cost, the time, or the probability of success? Great. Am I going too fast or too slow, or is this okay? Thank you. So I'll get to the answer to that question, and we've done that project. But to give you a sense of where the world is today, I want to show you maybe about 10 postcards from, not from MIT, but from all over the world, just so you can see what people are doing with genetic engineering. So this is a project from Mitsubishi in Japan, where they took the genome of one organism and they moved it into the genome of a second organism, the blue and the red, to make a composite genome. This is a hack. It took them 7 years to do this. And the result